Hello and welcome to my channel, Private Research. Thank you for watching my video. Today I'm going to teach you how to configure a StarDelta or how to design a StarDelta circuit for our AC motor using the application EKTS. And today in this little demonstration and this presentation, I'm going to show you or we are going to learn after this presentation the concept of normally open and normally closed contacts, learn the concept of switching state and relays, the timer relay working concept, the star connection configuration, the delta connection configuration, the star delta connection configuration, and the star delta connection configuration design on EKTS. So we have here how does normally open and normally closed contacts in our contactor works or function. The normally open contactor is in the idle state when the normally open when the contactor is in the idle state. The normally open contacts will not pass current because it's not connected to each other, but after we energize, the current will pass and these contacts will pass the current. But the normally closed, if the contactor is in the idle state, it's not energized, the current will pass because it's normally closed. It will pass the current, but after contactor is energized, no current will pass because it opens the contacts and it dismantle from each other. And how does it look like? Here we have a contactor. It looks like this. This is a normally closed contact, and this is a normally closed contact, and this is a normally open contact, and this is a normally open contact. If I attach a wire here on the normally closed and attach another on the normally closed before the contactor works, it's going to pass the current. But if and after I attach, after I de-energize my or after I energize my contactor, the current will not pass from here to here, and vice versa, or the opposite will happen on the normally open. The normally open will not pass current if I attach a wire here and another wire here, but after I energize my contactor, the current will pass from here to here. So this is the concept of normally open and normally closed contacts in our contactor. And also I would like to demonstrate how does we energize our contactor. We feed here, we give the A1 a hot wire that contains 220 volts, and we give the neutral here and we attach the neutral wire here, so our contactor will be energized once we give it at 220 volts from here, or maybe 24 volts, or maybe 120 volts. It depends on how the contactor is was built. Is it built to work on 120 volts? Some countries works on 240 volts. Some countries it works on 24 volts or DC volts. Okay, how a relay work? It works on the concept of changing state from of its auxiliary contacts. It has two contacts. It has a normally open, two contacts normally open, and two contacts normally closed. And we set a time or adjust a time, and after this time pass, and after we energize the timer and adjust the time, these contacts will change state. The two contacts that is normally open will change state to normally close, and the two contacts that normally close will change state to the normally open. And we can use this in the lightning system. For example, we can put a timer, and after for example after 6 a.m. we set time from 6 p.m. to 6 a.m. to on a normally closed contact or normally open contact, and then after 6 p.m. it will change state from normally open to normally closed, so it will pass current, so the lightning system will work. But after 6 a.m. It will change state, the normally closed will change state to normally open, and the current will not pass through the normally open, and it will return to its original state, and then the lightning system will turn off. And here we have in a Delta connection, the winding terminal is connected as the following. This is a Delta connection as we look here, as we see here, and this is the demonstration of how it's configured. Winding U1 terminal is connected to winding W2 terminal. Winding V1 terminal is connected to winding U2 terminal. Winding W1 terminal is connected to winding V2 terminal. Please note that terminal U1, V1 and W1 are connected to power source. The current withdrawn here by the motor is 100% of the motor rated current, and if the motor rated current is maybe 24 amperes, and the circuit rated current or your circuit rated current is 30 amperes, it will withdraw the 30 amperes, and you have to be aware because sometimes it may burn your windings, your motor windings. So before you attach or after before you attach your AC motor to your circuit, you have to be aware and check before you attach it the current that is on your circuit, that relies on your circuit, and if you wish to configure it as a Delta connection, or configure your AC motor for Delta connection, or you want it to withdraw 100% in order to get the full torque of your AC motor. And here we have the star connection. A star connection is highlighted here, as you can see. In a star connection, the motor windings are connected in the following manner. Windings terminal W2, U2 and V2 are connected with each other. Windings terminals U1, V1 and W1 are connected to the power source. The current withdrawn here from the circuit is 60% of the motor rated current, and this is a protective method in order not to get the full circuit load in your the full circuit load. Maybe your circuit is 400 volts, and your rated volts on the AC motor written on the blade is 220 volts. So in order to get the 220 volts, you attach your AC motor on a star connection, and this will withdraw only 220 volts from the circuit full load. So it will give you the torque that is needed, but don't attach it as Delta connection, because if you attach it and with a Delta connection, it will withdraw the 400 volts while the AC motor is rated on 220 volts, so it will burn the windings. So the only way that you can attach it is with a star connection. Here we see in this demonstration the StarDelta connection. We have here, for explanation, we have a circuit breaker, we have a circuit breaker, we have 3 contactors. One contactor is working as a basic contactor, and the other one, the second one, is working as Delta connection, which is lately it will work after the star connection. And the third one here on the left, on the right, is a star connection, working as a star connection. We have configured the star and the Delta connection externally, not inside the motor box, contacts box. So the Delta connection means that we connect the AC motor on a star connection first to force the motor to withdraw 60% of its rated current from our circuit. Then we transfer the connection to the Delta connection configuration in order to get the motor withdraw 100% of its rated current from our circuit in order to get full torque of our motor using transition tool, the timer relay, in order to fix the over starting current phenomena. And because after we attach our motor, it will withdraw about 9 times more of its rated current, and this could affect on your sizing and could affect on your devices. It could affect on your cabling, so you don't want this. You want to make it work on a small amount of torque, or have its rated torque. And then after the phenomena pass if after the phenomena pass, you can connect it as a delta connection, and this we use with big motors, AC motors, that works on a higher ratio of current and horsepower. Here we see here on the left the power circuit configuration that motor windings terminal are connected to contactors that function as a star and delta connection. It's externally configured, so we have contactor 1 functions as a basic power control relay, contactor 2 functions as a star connection, contactor 3 functions as a delta connection, and we are going to configure this on the application EKTS. Okay, right now we're going to build our StarDelta circuit for our AC motor, and we are going to use these components. Here is the motor, our motor, and here we bring supply, 3 phase power supply, and this is for the power circuit. Okay, I'm going to try to make it fast for you. Do it fast. Okay. This is a delta connection contactor. We're attaching it directly to the motor. Alright, and then we return to connection to the hotlines, the source hotlines. And here's the star contactor. So we have built our power circuit. We're going to build our control circuit. Okay. As we said, we have 3 contactors. This is a start button, and this is a stop button. Of course, it's going to be before the start button, right? And then we have our normally open contacts. This is contactor 1 latch, and also normally open contact is for our contactor 3 latch, contactor 2 latch, I'm sorry. We connect here to the neutral line. Okay, we're going to connect all the contactors to the neutral line. And then we're going to connect timer relay and on timer relay. And so we set the time for 10 seconds in order to pass. After the phenomena pass, it will turn the connection from a star connection to a delta connection, as we have explained. We call it T1, and this is a delta contactor, call it KD, and this is a star contactor, we call it KS, and this is a basic contactor, we call it K1. Alright, and then we latch here our contacts, our open normally open contacts. This is for the basic contactor, and this is for contactor 2, which is the KS. And then we're going to put here 2 normally closed contacts. This is going to be for the delta contactor, this normally closed, and then this one is for the timer. Alright, and then we're going to connect the delta contactor, and we're going to put a normally open, 2 normally open actually. This is normally open, this is the latch for delta contactor, and this is for the timer contactor. This is going through the timer relay, and this one is the latch of contactor number the delta contactor. So this is for the timer in order to energize the contactor, and then it will work on the latch. Okay, and this is the timer. We're going to give it from contactor the delta contactor a normally close, in order that after it is energized, the normally close will turn to normally open, and the timer will turn off because we don't want the timer to continue starting after we transfer the connection from star to delta. Alright, so when you give it a normally close the contact, here we'll go, okay, and then here it is. Then here, this is delta contactor, normally close, and then this is we name these contacts normally open contacts. This is a star contactor, connection contactor, and this is a delta connection contactor, and this is a basic contactor. Alright, and then we turn on the power and see how it's going to work. Please observe that it will work first on the star connection, and then after the 10 seconds pass, it will work on the delta connection. Just observe what's gonna happen. As you can see here, it's working on the star connection, and 6, 5, 4, 3, 2, 1. Now we are working on the delta connection, so we have avoided the phenomena that of starting current, because the current is withdrawn is 9 times the over 9 times the rated current. So we have avoided this phenomena by the star delta connection. And thank you guys for watching my video. Please subscribe, and if you have any questions, please leave it in the comment. Thank you.